Hey everybody, this is Mrs. Peachy from your WCA Earth Science class, and what we're doing today is I'm going to be doing an alternative portfolio for your Geologic Age lab. So here you are an Earth Science student and you don't have the materials to do the Geologic Age lab, so instead you're going to be doing this alternative portfolio. Let me just say that I would prefer that you did the hands-on lab, so if you do have the ability to get those materials, please do that. So don't make this one your primary or your first go-to, okay? So let's just say you don't have the materials, so you have to do something different. So this one enables you to do something with Half-Life, with Geologic Age, but you're doing something on the computer instead. So first thing you're going to do is you're going to go to my website. Remember that if you click on that push pin icon at the bottom of your window, this is just going to open up my message boards. And if you follow the links here, you should be able to get right to my website. Now, I already have that opened here. So I'm going to bring that one up. I don't actually... Here. It's right here. I just have too many windows open on my screen right now. Okay. So here's my website. Remember, you're clicking on that little tab that says Earth Science A 2019 at the top of the screen, unless you're watching this in 2020, in which case this may not say 2019 anymore, but it will say Earth Science A. And you're going to go down here, and this first is the actual hands-on lab that I would prefer you did, but again, you're doing the alternative lab. So when you click on that, that's going to open up this document. Radioactive dating game. You're going to go down here to this clickable link and you're going to open PhET, and that's what I had opened before. That was this one that just popped up here and kind of got in the way. But PhET is an online, kind of does these virtual labs. It works out really well. It does things across all sorts of science content, so it's actually pretty cool. You're also going to download this into Microsoft Office, and you're going to open it up as a Microsoft Office document, which I already did for you. And you're going to be completing this and turning this into me, saving it, turning it into me in the Dropbox in the next lesson. Okay, so in that last lesson where it says Geologic Age Lab Submission is where you're going to turn that in. So you don't need any materials for this at all, okay? So first thing is, it says, you're going to click on the HalfLife tab. That's the first thing. So when we go to this Java program, at the top there's tabs. HalfLife, Decay Rates, Measurement, and Dating Game. The first thing you're going to start with is the HalfLife tab. I'm going to bring this up here, but I'm actually going to put it on my other screen because I would like you to be following along with that. The first thing it says is click Add 10 and watch as the carbon-14 changes to nitrogen-14. Look at the chart on top to see where the half-life is and fill in the data table for carbon-14 or C14 and for U238. So this took me a little bit to kind of figure out what they wanted me to do here. What you're going to do is you're going to start by adding 10, and then you're going to let this thing run, and as soon as it crosses that half-life line, you'll pause it real quick and see which isotopes, what number you have. So we're going to select carbon-14, and we're going to add 10, and then we're going to let it run and pause it the second the little red ball crosses the half-life line, okay? Okay, so it just crossed it. All of these are before the red line, which is what I want. And it says right now I have 3 carbons and 7 nitrogens. Okay, so when I go back to my Word document, I'm going to put that there are 3 carbons here. Okay, that's how many I have left. You can run this a couple of times because you're going to notice that that's going to actually kind of change a little bit. So if I reset this and I do it again, I have 4 this time. And if I reset it and I do it again, I have 6. So now we've had 3, 4, and 6. It's kind of giving you right around the same number, but it's changing a little bit each time. So that's kind of an important piece of information. If you average those together, 3, 4, and 6, it's giving you about 5 each time, right? So You don't have to do the average, but I want you to realize that it doesn't give you exactly the same number each time. The next thing you're going to do is add 10 more, and then rerun this. Now you've got a total of 20 atoms. Reset everything and rerun it. And pause. It's got 11 carbons. I'm going to do that again, just because I want to see if that number changes. Got 10 carbons. So I'll go with 10. I think the last one had one that trailed over the edge anyways. And I'm going to go ahead and just put down that I have 10 here. Then I'm going to add 10 more. Reset all, add 10, do it again. Okay, get 16. Now, you're going to continue to do this. You're going to add 10 more, reset it, rerun it for 40. Add 10 more, reset it, rerun it for 50. Once you've done that, you're going to go ahead and switch to the next element, which is uranium-238, and you're going to do the same thing. You're going to add 10, run it, pause it. We started off with, now we have 6 uraniums here, and 4 leads. So 6 is the number we're going to put on our chart here. Okay? And we're going to, again, do exactly the same thing. Add 10, reset, and rerun. Do it for a total of 20 now. And do it for 30, and do it for 40. And then you're going to come and answer these questions about how many atoms are expected to decay before the half-life is over. You have to remember the definition of the half-life, right? According to what half-life is, you would expect half of the atoms to decay when the half-life is over. When you have 10 atoms for your first example right here, you would expect there to be 5 that decayed and 5 that remained. But it's not always perfect. Why do you think it's not always perfect? Yes, it's a computer program, but that's not the reason why. In reality, if I have a sample of something, let's say I have a sample of carbon-14 and I wait out the length of its half-life, 5,730 years, I might not have precisely half carbon-14 and half nitrogen-14. It might be a little bit different, right? But remember that half-life averages the average half-life. And also remember that as each atom is decaying inside here, it's a random thing. So it's not always going to be exactly the same because it's approximately half, but every atom has a 50-50 shot each time. So the total number is kind of a little bit more random. And then what is the big difference you see in the decay of uranium compared to carbon? Then it says choose custom and move the half-life bar on the chart and choose a decay time. You can do this. Hit custom. You can make your own half-life time. But the bottom line is that no matter what you make the half-life, that you should have half the number of atoms after the half-life that you had before the half-life. So if I have half-life here, and I start with 10 total, right? 5 and 5, 10 total. If I reset everything and start over, after the half-life, I should have approximately 50-50. I won't always have 50-50 because of random chance. But after many, many trials, my average is going to be 50-50. See, sometimes it goes one way, sometimes it goes the other way. But if I average it all together, it's going to be 50-50. The next part says, now you're going to the Decay Rates tab. So I'm going to go to the Decay Rates tab at the top of the screen. What this is telling you is you're going to be adjusting this slider here, okay? I can start with very few atoms, and I can let it run. Oh, I want to reset it. Yes. Okay, wherever these two lines cross is the half-life. It's about, well, I shouldn't say that, but whatever these two lines cross is where we get 50-50. Okay? The half-life is the red line. So I'm resetting this, adding more atoms. What do you notice as I have fewer atoms versus more atoms? In which situation do you get those two lines crossing closer to the actual half-life? When you have very few atoms, or when you have lots and lots of atoms? And why would that be? Why would it be that the more atoms I have, the more likely that my measured half-life is closer to the actual half-life of that element? Why is that? Why does the number of atoms matter here? Again, think probability. Think statistics here, okay? So for this one, it's just asking about, does the number of atoms at the beginning matter? What did we talk about a minute ago? And what do we call the time where the original atoms and the decayed atoms are equal in number? At that point where it's 50-50, that is called what? Hint. It's the name of the lab. That's what we've been doing this whole time, right? And then we have the measurement tab. We're going to go up to the measurement tab next. And here, we're going to start with clicking on tree. And we're going to plant a tree. And it says to pause it after 3 half-lives are reached. So I can plant the tree, and I can let it grow, and then the tree dies. And then it can, oops, I want to click on carbon-14 up here. That's important. I'm going to reset this, okay? Because I should have clicked on carbon-14 to begin with. Now I'm going to plant the tree. It's going to grow. It's getting older. It's dying. Boom. Now the carbon-14 starts to go down. And it was at 100% until it died, right? And now it's starting to go down. No, it's not starting to go down. Something's going on with this one. I don't know why. I'm going to reset this one more time. This was working fine for me before. I guess we'll just hit kill tree, because if we don't hit kill tree, maybe it won't come down. Okay, I'm just going to reset this, guys, because it's not working for some reason, and it shouldn't look like that. So let's try this again. It worked perfectly fine when I was doing this earlier. Okay, just give me a minute here. I'm gonna actually pause my video. We're gonna look into what's going on with this. Hang on a sec. Okay, I figured out where we were going wrong. Because I had been playing with this earlier. You probably won't have this problem because it didn't reset all the settings. You do need to make sure that this is checked objects and not air. It's giving you like a sample. It's sampling the air right now, which is what we were doing. We need to sample the object. It should be a microphone that comes down. If there isn't a microphone that comes down, then you need to make sure that you select objects. Carbon-14 is selected, and then we're going to plant a tree. All right, now it should work. All right, now we're sampling the carbon-14 in the tree. You can already see it starting to drop because the tree dies. Carbon-14 is only found in living things. So when they begin to die, all of a sudden they're not respiring anymore. They don't do respiration. So they're no longer adding carbon-14 to their bodies. Okay, so it says to let this wait for 3 different half-lives. So we're just going to kind of let it sit there and tick out. And the question it asks here is, what happens to the amount of carbon-14 when the tree dies? You need to answer that question. I think it's pretty much self-explanatory. I don't know if you really need to wait until all 3 half-lives have passed in order to decide what's happening to the amount of carbon-14. The second question you'll see here says, If you found a piece of preserved wood and 65% of the atoms were carbon-14, how old is it? Well, you can do this by just resetting this again, planting a tree, and when it gets to 65%, we're going to pause it. It's going to grow. It's a living tree, so it's replenishing its carbon-14. It dies. When it gets to 65%, we will pause it. I'll let you do that because I'm not going to do your work for you. And when you get to 65%, you're going to see how old the tree is. It'll say it right here. So then you'll be able to get that information. Okay, how old is the wood if 65% of the atoms was replaced? Then it says you're going to go to the rock, and you're going to click on carbon-14. And it says here, why is there no line forming on the graph with the rock? If I hit rock and I hit erupt volcano, so I'm going to put a rock on there. Why is it that we don't have any carbon-14? I'm going to cool that rock down. But there's no carbon-14. There's no percentage on the graph. There's no line forming on my graph. Why? Why is that? Hint, remember what we said about carbon-14 and why it's 100% in a living tree and it starts to reduce when the tree is dead? So it's very important that the object must be like a tree. What do trees and people and everything else have in common that have carbon-14? That is your hint, okay? Let's reset this. And then the last thing it says on here, it says is, okay, so now we're going to click on uranium-238 and we're going to do the same thing. So we're going to go to uranium-238. We're going to erupt the volcano. Boom, boom, boom. We're going to wait here. Oh my gosh, a person just came out of the volcano. We're going to cool the rock. And now we're going to watch the uranium-238. Now it says why do we now see a line forming on the graph? Okay. And then finally, the last section, which actually takes the longest here, is going to be on the dating game tab. Remember that if 0.0 comes up in the black box, it means that that item does not contain that isotope. So if I go to the dating game tab, and I'm going to, it's all reset. But if I look at the elements, I've got carbon-14 and uranium, right? If I point my microphone at this bone and I click on uranium, it comes up 0% because bone does not have uranium. I have to use carbon-14. So I pointed at the bone, and now it says it's 83.9%. Well, if I look up here, I can use this little green arrow and I can move it until it matches, until it's at 83.9%. Close to it as you can get. You don't have to be exactly right. So I'm going to put the age down as 1,483 years. And it says it's right. Okay? And now I'm going to go to the cup. And it does not have, it's a wooden cup, I guess. So it does have carbon-14. It says it's 88.2%. So I'm going to go try to get as close to that as possible, which is 1,000 years. And it says it's right. And then I'm going to point it at the skull here. 76.6%. Good. Perfect. 2,207 years. Okay, now I have to add these three up and divide the total by 3. So you're going to add up the 1,483. Okay, so we're going to go 1,483 plus 1,000 plus 2,207 equals, and then hit divide by 3 because there's 3 entries. And that gives me 1,563.333, but I'll round to the nearest whole number. 1,563, which is the number I'm going to put here, okay, as my approximate age. Okay, so now you are going to have to complete the age of each other layer, the light gray, the pink, the yellow, and the, I don't know what colors they call these though. They call them blue, pink, yellow, green, and light gray. So just in order, right? Some of them are easy like those that I just did. Some of them are a little bit trickier. For example, when you get to be pretty old, like this kind of stuff, you can't drag this far enough over. It only goes down to 10.9%. So you're going to have to kind of do a little bit of estimation here. You may end up having to do a little guessing and checking to be able to get the right age of the skull, okay? There's a bit of math that you can do which helps a little bit, and I'll show you that real quick right here. Let's see what I can do here. Hang on. All right. So what you can do, uh-oh. Come on. Where did it go?